Hi there, I'm Hao, and this is just another video of me solving random code problem. So today we need to design a minimum stack, min stack, with the following function. So we have, let's see, we have the constructor, right? And then push, which is pushing an element onto the into the stack, pop, remove the top element on the top of the stack, top, right? Get the top element of the stack, and then the only special case here that we don't normally have in the stack is the yet min, right? Which is we're gonna retrieve the minimum element in the stack. And the requirement is that we need to do it in O1. So um, this for our function, we can easily do it in O1, right? Just like constant lookup in array. We can use an array to keep track of to view our stack. But like we can use a variable, right, to keep track of the minimum as we adding more element into the array, right? So like this. So if we push 2, right, put -2, right, the minimum is this. If we 0, it is still the minimum, right? Minimum, put -3, right? The minimum now become this one, right? So this is working if we never pop anything off the stack, right? What if we pop off the top of the stack, right, which is the -3 here? Now, how am I supposed to know the next minimum, right? We need to iterate through the array again. That will give us a O of n, right? Okay. So what we can do instead is that we can keep track of the minimum up to a certain index, certain interval, right? So for example, instead of storing the only the value, we can store the value, right, to the mean, right? So the value is we got -2, and the minimum gonna be -2. So the minimum of the stack, right, up to this index is -2 because you only have one element there, right? The next element is 0, and the minimum is still -2, right? So the minimum up to this index, right, will be -2. The next one is 3, -3, right? And the minimum up to this index is gonna be -3, right? Okay. So if we get min, we're gonna get this number, right? So whenever we get min, we can just simply look at the last element, right, on the stack, because the last element on the stack, the top element, right, gonna be the min we contain a minimum up until this index, right? So we can just return index one of the subarray, which is -3. If we pop -3 off the stack, right, and we do the get min again, right, we can just look at this element, the last element, right, which is -2, right? So the minimum up to this index is -2. And we never have the prompt doesn't mention that we have to pop up the mean, right? So we don't have to worry about that. Okay, so using that strategy, we can store a little bit more information in exchange for some in exchange for a better time complexity. Okay, so let us code this up. So this is our constructor. We're gonna have our stack. Should we push something onto the stack? We just start a push, right? The value, the value, right? So there are two cases, right? So if the stack is empty, right? The minimum one just gonna be like the first number, right? The first minimum, right? Right. The first number gonna be the minimum. Okay. But if it has more than one element, we need to compare, right? The minimum. So what is the minimum? So the minimum is gonna be the top element of the stack, right? So this is the stack line minus one, right? And we're gonna look at index one, right? Of the subarray, index zero is the value, index one gonna be the minimum, right? And we're gonna push a new element. The first value is the value, right? And the next value gonna be the minimum, right? But that mean the mean and the value. Okay. Top, we can just simply just the top, do the stack of top, and we don't have to return anything, void. So for top, we need to return the element at the top of the stack. So this the stack, right? The last element is this the stack of line minus one, last index, right? And we need to return the value. So index zero. For the get min, we can look at the last element on the stack, right? And return index one, which is the minimum. And yeah, that's pretty much it. Let's try that. Okay, time limit exceeded. So let's see here. The minimum gonna be the last element at index one. That makes sense. Um, the top right just gonna be at index zero, the last element at index zero. So that's also makes sense. A pop, we just pop it up, right? Um, okay. So the construction looks good. So the problem might be in this method here. So let's look at it again. If there's a stack of length is equal to zero, which means we only have zero element, right? And the first element here gonna be the minimum, first minimum, okay? And then you're gonna get the in else, which means we have more than one element. So we need to check for the minimum, right? These are stacked, the line minus one. So we look at index one here for the minimum. And then we need to push, okay, this is stack dot push the value and the new minimum, right? So just a typo here. Let me try it again. Okay, line 36. Oh yeah, this is stack dot length. Okay, same for here. Okay, now it worked. And thank you for watching.